Hi everyone, it's been a long time since my last video. I'm often asked what are the best approaches to use NiFi to push data into data warehouse solutions. There are many options, so I want to do this short video to explain a few options and discuss the pros and cons of each of those options. So in this case, I'm using Cloudera public cloud with a NiFi cluster deployed as a data hub cluster. So really NiFi on VMs, nothing fancy. Classic NiFi, it's using NiFi 125, which is the latest NiFi. I also provisioned a data warehouse solution using Cloudera Data Warehouse, where I have my Hive and Impala query engines where I can query data. So here, I just remove the table. So if I do something like this, it will fail because basically I don't have any table yet. So I'm going to start creating a table, something very simple. And I'm going to use the Iceberg table format. So create table customers, a few columns. The ID column is a primary key. I'm partitioning based on the country code. You can, for example, assume that this partition will be used to limit what one can query. Assuming that you are in the US, maybe you can see only the data for people in the US and these kind of things. So partition by country code and then stored with the Iceberg format and the V2 of Iceberg. Okay, so I'm just taking this. I go here and I create this table. So now I have this table, as I said, Iceberg format, and now I want to push data into this table. Okay, so I have my table here, and if I do a select star from customers, I won't have anything, no reasons. Okay, so now what are the options? So I'm going to generate data. Here I have a generate flow file, and I'm just generating two records, right? John Doe ID1, Jane Doe ID2, not the same country code, and then last seen at, which is generated with the current time. Okay. Very easy, obviously not a real use case. You would likely get your files from some object store location or I don't know, get data out of Kafka or whatever, depending on your use case. Here it's just an example. I'm going to push into the database default and the table customers. I'm using this as flow file attributes. So the first option, since my destination table is using the Iceberg format, is to just use the PutIceberg processor. Very easy, nothing crazy. I'm just saying my data is JSON, so JSON reader. I'm defining the Hive catalog service. All of the details around this are shared in another video. You can look into it. It's also very well documented. If you do have questions, please just ask the questions in comments of this video. Catalog namespaces, database name, table name, and that's it. And then credentials to authenticate. Very easy, very straightforward. So here I can generate my data here. If I list the queue and I look here at my data, I can see I have my two records with the date that is right now. And I can just push this data. Okay, so start the PutIceberg, and it's going to push the data into the table. And that's it. So since I didn't use it in a long time, it's taking a bit of time the first time, but now that everything is initialized, the data is sent and the data is pushed into the table. So now if I go back here and I select everything from customers, I will see my two records here. Now, something that may be an issue is that PutIceberg processor is really just about pushing data. It's basically only doing inserts, inserts, inserts. So what it means is that if I generate another piece of data here, this is going to send two new records. And if I select again the data, this time I will have 4 rows, and we can see that I have, again, the 2 same lines. So it's basically not doing any kind of merge operation or upserts or whatever. Like it's really just pushing the data. That is great, and that is extremely efficient in most cases. But for some use cases, maybe it's not exactly what you want. So there is this option, but now we can look into other options. There is another option here, which is just using PutDatabaseRecord processor. So in this case, it's really ignoring the fact that the destination is Iceberg. We are just going to use JDBC to talk to the query engine and send the data over JDBC. So in this case, I'm just using a JSON reader. The database type, I'm saying MySQL. It's just for generating the SQL statements. That's something we don't really care about. But actually, we will do an improvement here so that we can add additional options here. That's something we will be working on. So that, for example, you can have a dedicated Impala option here. Because for some queries, the syntax is going to be specific. So MySQL here, and here I'm using the insert statement type. Impala connection pool. So here, if I go into this controller service, that's something very easy where you can just specify all of the things. So here it's the driver version that is already embedded into the NiFi distribution so that you don't have to worry about it and distribute anything. Database hostname and port is basically what you would get out of here with the JDBC URL here. You can just retrieve the different pieces of the JDBC URL to configure all of this here. We use the HTTP transport mode because we are going through a gateway, and we use username password authentication. I provided everything. I provided the TLS context service for the trust store, and that's how everything is configured to be fully secured. So now if I run, I will empty all queues, stop this here, and I can run once here, and I can do here, start the PutDatabaseRecord. So again, this is really over JDBC, and it's doing the insert statement. So since it's doing an insert in my table, I will see that I have 6 records now. So it's really not caring about the primary key. So ideally, what we would want to do here is actually use upserts here. But as I said, we need to do an improvement, and we will be doing this shortly, where we need to have a database adapter specific to Impala so that upserts statement is correctly generated. So that's something we will be adding. But basically, you get the idea. With PutDatabaseRecord, we are just using JDBC and sending the data like this. This is perfectly fine for use cases where you don't need to send crazy amount of data. But if we are talking sending millions of records, huge datasets, doing JDBC is probably not the best option from a performance point of view. So there is another option that I want to discuss, which is, as you can see, a bit more complicated in terms of how many processors you need. But this is a very common pattern that most of NiFi users are adopting when it comes to pushing a lot of data into data warehouse solutions. And it's providing more flexibility, more options to do exactly what you are looking for, and it will also be more performant. So I'm going to explain what I'm doing here before I actually run it. Let me empty all queues here. Okay, so the first step here, I don't know why I have an update attribute here. Oh, yes. So basically, at a very high level, before I go into each step, the idea is I push my file containing the data into a staging location which is the object store on top of which my data warehouse solution is running. I create an external table on top of that file, and then I run a query to merge the content of that table into my destination table. And then I can delete the external table that I previously created and delete the file. So that's really a common approach. There is, like, you can have a lot of variations with this approach. As I said, it's very flexible. So maybe you don't want to delete the files at the end. Like you can have many different approaches. But basically here, what I'm doing is, so I have my flow file that is coming in with my data. Here, I'm creating a new attribute, which is based on the UUID of the flow file, where I'm removing the dash symbols, because I'm going to use this as the name of my external table, and I can't use dashes. So I just do this. So let's do it here. So I create this flow file attribute so that I'm going to use it for creating my table. Then here I convert the data into Parquet because it's just easier to create a table on top of Parquet. So I'm just doing this conversion. So I'm running this, conversion is done, and then I'm sending the file into the object store that is under my data warehouse. So in this case, I'm running everything in AWS, so it's going to send the data into S3. The PutCDP object store processor is a processor that is available with the Cloudera distribution of NiFi, which basically works regardless of which cloud provider you are using. So instead of using PutS3, I can use this processor, PutCDP object store, and the same flow definition will be working exactly the same on AWS, on Azure, on Google Cloud, even on-prem. So that's the reason why I'm using this processor here. But you could use PutS3 in this case. So I'm pushing the data here. So it's actually going to push the data here in a staging directory that I created. So the file is here. I created a directory and I have the file here. So that's what I have. So I created a directory specific for that file, and now I'm going to create a table on top of that file. So what I'm doing here is create external table, ID, name, last seen at, country code. You see that I'm not doing any kind of partition. I'm not using Iceberg. I'm just doing straight creation of table, stored as Parquet, and I'm giving the location, which is the directory where I just sent the file. And I'm just doing this, and I'm using the Impala connection pool to create the table. At this point, like, the data has been sent already, right? So I'm just creating a table on top of it. So like, it's just a create table statement, very fast, very quick. So here it's executed, and now if I refresh here, I can see that I have my table here. And if I select on that table, I will see that I have my two records here. So very straightforward, nothing crazy. Now the second part is merge into. So I'm going to use the Hive engine, and I'm using the Cloudera Hive connection pool to do a merge of my table into my destination table. So I merge into my destination table, and I select everything from the table, external table that I just created. And here I can be quite advanced. Like, if I have very specific business requirements, I can do something very advanced here. This is really up to you and to your requirements. In this case, I'm doing a merge based on the idea so that I can only really take into consideration the primary key and merge the data. So I'm not going to create new rows if I already have rows with the ideas. So that's a merge statement. So here I'm running this, and this is, I'm just sending the query, and then it's the query engine and how much resources you have on the query engine that is going to take care of this. So here in this case, I think my Hive warehouse probably stopped when I was talking because we are not keeping the resources running. No, it's here. So, okay, so it's been executed here. So we merged the data. So now if I go back to here and I select again from customers, what I'm going to see is that I actually merged the data. So since I already had rows with the idea, here you can see what I'm doing. So basically, I updated the last seen at for each row that I already had, but I didn't create any new row. So in this case, I really did the merge statement. So now I can just go to the next step and just say drop table. I just want to drop the external table that I created before. So same, very quick, and then delete the directory where I pushed my file. And here, if I look here again, the data has been removed. So I did something very clean, and now the data is merged into my final table. So the data is sent into my Iceberg table with the partition and with any specific conditions I need on that table. In this case, really look at the primary key and not duplicating rows depending on my business requirements. So that's the approach I'm taking here. At every step here, create table, merge into drop table, I could have a very specific failure handling so that if something wrong is happening, I can get back to it. So for example, I would probably do some logging or monitoring into some database to say, okay, this file was not processed correctly and it failed at the step create external table. So I would have the file in my object store, but I wouldn't have the table on top of it. So I would need to look into it. The merge statement, maybe because of some bad data or something like this. So same, I would have the external table. So my data will be available in my external table, but I will need to look into the merge statement. The drop table fail, very unlikely, honestly. But yeah, if the table has been could not be dropped for some reasons, you could look into it and do something manual if needed. So here, this approach where you split things, each steps, is interesting because you can have dedicated failure handling depending on what you want. So a quick summary of everything I said, because that's really what I wanted to show today. When it comes to pushing data into a data warehouse, you have many options. Here, you could say, okay, this is an Iceberg format table, so let's use the PutIceberg processor. And yeah, just do this, push into Iceberg. But as I said, this PutIceberg is really taking the file, pushing the file, and creating the snapshot, updating the metadata of the table, and so on. It's not doing anything fancy. So it's really just pushing additional data in your destination table, which, as I said, is fine in most cases. The next option is really push the data using JDBC. This is also perfectly fine in most cases, but if you really need to send huge amount of data, JDBC is going to be a bottleneck. So it's not really great if you have a huge amount of data. And finally, if you are really pushing a lot of data and you just want to let the query engine do the work, then this approach, while a bit more complicated in terms of flow design, is way more consistent, I would say, because as I said, you just push the data into the object store here, so S3 or ADLS or GCS or HDFS or Ozone or whatever object store you are using below your data warehouse. And then using JDBC, you just execute some SQL statements and you delegate the work to the query engine. So here, create external table on top of my file that I just pushed before, then do a merge into. As I said, here you can be as fancy as you want, depending on the options provided by the query engine. So really up to you. Here I'm doing something very specific using Hive merge into capability. But again, you can do anything that is supported and required in your use case. You could just do insert into select star, something like this. Like it's really depending on what are your requirements. And then drop the external table that you created at the state before and delete the files if you don't care about the data now that the data is in the final managed Iceberg table. So yeah, that's the approach. That's something very common. All three patterns are very valid, but it really depends on what you need and what are your expectations and how much data you are going to deal with, performances you are expecting, and things like that. So it's a common question that I get. I wanted to make this short video to go through in each option. Feel free to ask questions in the comments. Thanks for watching. And it's been a long time since my last video. I will try to be a bit more consistent in making videos available. So feel free to suggest in the comments what the next video should be about. I have some ideas of videos I want to record and share with you, but always open to ideas if there are things you would like me to talk about. Thanks for watching, and see you next time.